Dear students, good evening. Uh, uh, Last class we discussed about density measurement, right? So in that we have covered different density definitions, right? And and Bion's effect, density meter, right? And so what are there remaining pressure head type and displace type, right? And so yesterday we covered some other concepts like density meters, right? And this time we see the other concepts like uh, like uh, this one, hydrostatic, hydrostatic type, right? Yesterday what we covered the hydrometers, Beyonce type, right? And cyclometer, cyclometer. These are all covered yesterday. And today we'll see the hydrostatic weighing density meter. This is a hydrostatic type, pressure head type, right? And in this, see the diagram, hydrostatic weighing density meter. In this, how this unknown fluid density is going to be measured means, uh, with this arrangement, see, uh, there is a pipe, is a pipe having two ends, end one, end two. It is a two opening. Through this flow is inside. The fluid whose density is to be measured, that is inlet. That is inlet like this, right? And that is coming outlet like this, flow out. And for this pipe, there is a supporting weighing system and bellows. Bellows are arranged. Bellows are arranged. So what happens? So in this hydrostatic weighing method, it is consists of a U-tube. It is a U-tube that is pivoted on flexible end couplings. So it is fixed and somewhere, and the total weight of the tube changes depending on the density of the fluid flowing through it. So, how the total weight of the tube is going to be changing based upon the density of the fluid flowing through it. When the fluid is flowing, the weight is going to be changed. So, the change in weight needs to be measured. How the change in weight to be measured? So, there should be there are number of methods involved. The most common commercial one is uses a force balance system. It uses a force balance system, right? And so, what are the force balance system? Force summing devices like bellows, stainless bellows available. So bellows are connected here. So then they will have some force balance system. So when the fluid is flowing, the bellows are moving. Bellows are moving. So thereby we are getting an unbalanced. Unbalanced. Initially it is balanced. Now when the fluid of the unknown is flowing, it is unbalanced. That unbalance is going to be measured, right? Uh, so that unbalance is proportional to that this density of the unknown fluid. So there are some advantages in this. Some advantages here. So this is very accurately given the values, right? It is red because in any slurries and sugar solutions, powders, this method is very much useful, right? And there will be some disadvantages also here. So they should be installed horizontally on a solid base. This is a difficulty we are facing when we are installing this type of model, right? And the meter is not flexible enough to adapt to any process. That process must be designed around it. So we need some flexible meters for this, but they are not available, right? Typically, right? And there are bulky and uh, unable to use it properly because their size is vary. The size is going to be vary, and they are unsuitable for gas density measurement. So this method is suitable for liquid liquid type than the gas type, right? And one next one is a balance sheet. Actually, it is not available in the as per syllabus. Balance system. Anyhow, you have to know. It's very simple. In the balance system, uh, see in this balance system, there is a weighing device. Weighing device is a flow vessel. Flow vessel. There are two openings. Liquid inlet, liquid outlet. So before the liquid inlet, see that weight of the system, right? And we have some scale that will give some weight of the total system. And when the liquid is inside and that is liquid is outside, in between, you have to see that weight. That weight will give the value of the density. This is one method, or this another method. Liquid in, right, and liquid out is another method. Using some LLDT concepts, liquid inside, and because of this, there is a variation of this plummet, So the voltage induced in this coil, that is proportional. That induced voltage is proportional to the amount of density of the unknown liquid. Like this, that is going to be calibrated, right? And next one is for these gases, gas specific weight balance system. In this, what happens? This is a complete chamber. This is a scale, right? Is a displacer weight. Displacer weight. It looks like a what is called um, um, what is called like elastic number. Say when the gas is inlet, initially it marks zero marking. Before gas is inlet, the scale is towards the zero marking, right? And the manometer shows some minimum value. That is called from here to here. This is the minimum value. Okay. When the gas is inlet, that gas density is going to be calculated like this. When gas is inlet, this displays a weight. Weight is displaced. When the weight is displayed, the scale towards some value. And the manometer showing some other value. So that value shows that the known density of the gas value, like this. And this is also some other that type of manometer. It is not available. It is not the concept of your syllabus. And next one is vibrating element density. Vibrating element. In this vibrating element means, so see, in this vibrating element, if a body containing or surrounded by a fluid is set to resonance at its natural frequency. Okay, then the frequency of oscillation of the body will vary as fluid properties and conditions are changed. So, when the body surrounds a fluid of the unknown density, it experiences some natural frequency. So, when the body experiences some natural frequency, so the body gets some oscillations. So, why the body gets some oscillations? Because of the fluid properties and conditions are going to be changed, right? So because of that natural frequency is directly proportional to stiffness of the body and inversely proportional to the combined mass of the body and the fluid. So based upon this property, we are measuring the density of the unknown fluid. It also depends upon shape, size, and elasticity of the material. induced stress, mass, and mass distribution of the body. Right? So what the relation between these like this. Resonance frequency equal to square root of k by m plus k rho. Okay, so where rho is the density we have to measure, k is the stiffness, and m is the mass, k is the system constant, rho is the fluid density. That density we have to measure. Okay, that can also be measured with the help of magnetic concepts, magnetic principles, and piezoelectric principles. Right? Uh, okay, and one more is the density tube density meter, vibrating tube density meter, vibrating. So based upon the vibrations, it comes under piezoelectric, comes under piezoelectric concept. So when a fluid passing uh, through some the tubes, what happens? It is going to vibrate. When it is going to vibrate, what happens? It gives some signals. That signals may be amplified and measured that is proportional to unknown density of the liquid. Like this, that measurement process is going on. Okay? See, the same vibrating tube is measured here. Liquid is inside, right? And they are called bellows. When the liquid is inside, bellows have some dynamic range. They are going to move, and they may have some experience. The fluid is passing through this pipe. The coil will drive. The coil will drive, and the liquid is outlet. Right? So, because of this bellows movement, we have some voltage in the coil. Voltage in the coil. That voltage proportional to the unknown liquid density. Like this, yeah, this is the way how this is going to vibrate, mode of vibration. Right? When the liquid is inlet, the liquid is going to be vibrated in the tube. Right? When it is vibrating, we have some signals that is that the amplitude we have to measure it. And of course, it is a pipe we are taking. Here we can take cylinder. Both are same. Dimensions are different, right? And it is tuning for density meter. It is also going to give some vibration. When these two are dipped into the see uh, when the two tuning forks are dipped into the solution, what happens? So we are observing the natural frequency. So to explain some natural frequency, that frequency we have to measure. Yeah, see, 2 in 4 density meter. Twin forks. Twin means here this fork and this fork. These two are inserted into the fluid. The natural frequencies are measured at it. You have to measure the natural frequency. The natural frequency of the fork is function of the density of the fluid. Like this, it will measure it. So these are not included in the syllabus, but we are knowing. We have to know it. And yeah, this is available in the syllabus. Radioactive density meter. Radioactive. So how this is going to be measured? The density which is radioactive principle means as radioisotopes decay, they emit radiation in the form of particles or waves. So there should be some radioactive elements are there. They will emit some radiations in the form of particles or waves. Radiation, right? So this physical phenomena can be used for purpose of density measurement. See, the radioactive elements may emit some gamma rays. Gamma rays. So what happens? Just gamma rays are passed through the sample of the unknown gamma rays, right? So and the rate of arrival are measured. So there is unknown sample. Unknown sample is what? Unknown fluid. Through that fluid, if gamma rays are penetrating, that gamma rays we have to measure it. So how the gamma rays is going to penetrate? After penetration through the sample, that gamma rays you have to detect it. How can you detect that gamma rays? We have some detectors. That is nothing but scintillation detector. Scintillation detection. So that gamma rays will give you uh, will give you the amount of intensity. Amount of intensity. So density meter based on radiation methods can provide accurate up to 0.001 gram milliliter inverse. Many of these devices have self-diagnostic. It's not important. See, suppose if gamma rays of intensity J naught penetrate a material of density rho and thickness of d, then the intensity of the radiation after passing through the material can be expressed like this: J equal to J naught e power n rho d, where n is the mass absorption coefficient. Any fluid, if it is experiencing radiation, it absorbs some radiation. It absorbs some radiation. Generally, if it is absorption coefficient is very less or unity, we can have the J. What is J? J is the penetration material intensity. That intensity proportional to the rho value. So when the gamma rays passing through the liquid or fluid, after measuring the intensity, based upon the intensity value, we can estimate that how much density of the fluid is having. We can estimate, right? So if intensity decreases, uh, if intensity decreases means what? Right? Density is less. If intensity is as big, density is high, like this one. We can have that radioactive principle. Radioactive principle. So radioactive means generally we are using radioactive devices like alpha, beta, gamma rays. By passing these rays, generally gamma rays, by passing these rays, by measuring intensities, we have to estimate the amount of unknown density of the fluid. We have the analytical instrumentation in the next semester. You may have B. Lambert's law. B. Lambert's law. There, I will tell you there. B. Lambert's law. All these radioactive instruments working on the principle of B. Lambert's law. Okay, I will tell you there. See, for example, how this light is penetrating. Say it is a arrangement. Liquid is inside. For this liquid, you want to calculate the density. Liquid is outside, and here is a chamber. Is a pipe. Pipe means a chamber. Here we have a radioactive source. Radioactive source. Here we have a detector. Receiver means detector. Scintillating detector. Bigger Muller counter or proportion counter, or sometimes ionization chamber. There are number of detectors are available. I will tell you later in the fourth one. In the fourth one, okay. So when the liquid is enter into the pipe, in this pipe we have to send radioactive source gamma rays. When the gamma rays are passing through the liquid or fluid, it is passing through and detected by the detector receiver. So there we are going to calculate the intensity. Based upon that intensity value, we can estimate how much density is presented here. Not only this type of pipes, straight pipe or bended pipe. This is a bended pipe like this. Liquid is inside, liquid is outside. So when the liquid is passing through, for the liquid, the density can be calculated by sending radioactive gamma rays, and that intensity are measured here. Okay, and there are some advantages with this radioactive method. The sensor does not touch the sample. See, is a sensor. What is sensor? Is a sensor, receiver. Detector is a sensor. Is a source. Source and detector does not touch the pipe. They are far from the pipe. So there is advantage. It is contactless. Not touch the pipe sample. Hence there is no backlog to the path of liquid. And multi-phase liquids can be measured. Multi-phase means different paths of the liquids we can easily measure at a time. They become in programmable form and easy to interface. You can interface these sections for other processing purpose. They are more suitable in difficult applications, right? They are very much important in difficult situations such as mining and heavy process industries. This is important. Heavy process industries because of contactless. There will be some disadvantages are there. Disadvantages. Radioactive source is needed. There's a difficulty and it is difficult to handle it. To make it some reasonable accuracy, minimum path length is required. Path length is a word that depends upon the light because where we are using the gamma rays. When we are using gamma rays, path length problem, there should be some path length problem. Okay, and there could be a long time constants making them unsuitable in some applications. Long time, take some time. They are suitable only for solid and liquid density measurements. Solid and liquid densities. But of course, there should be some other techniques are there with this radioactive one, which you can also use for gaseous system. Gaseous. Gaseous means we have some spectrophotometers, flame, flame spectrometer. I will tell you there in the final year subject. I will tell you there. No need now. So these are all your these are all our density measurement method. Density measurement method. Okay. Uh, so these topics are enough for you. If I miss any one of the topics in the second chapter, maybe in the viscosity or in the density, I will clear in the next class. Okay. You have I will don't worry about this, dear students. I will give you a complete material to you. I will give a complete material to you. Don't worry, just follow it. Okay. You have any doubts? I will clarify. Ask me. Uh, Ask me. I will tell you.